like to welcome everybody to the Java EE8 update. So we're going to switch back and forth throughout this presentation. So a quick overview of the agenda. So we're going to start off by looking at the specifications and their current status, look at the proposed enhancements, talk about the Java EE8 reboot from Java 1 of last year. Also, towards the end, talk a little bit about what they're proposing in Java EE9 and also how to get involved. How many of you know that the release of Java EE9 is imminent? Coming up? A couple of people. Okay, so it's going to be out there next month, actually, is the target release. So in terms of the importance of Java EE, it's incredibly important to both the long and short-term health of Java EE. I mean, there's not as many people anymore are developing desktop applications, so Java EE is really the heart and soul of Java right now and has driven its adoption throughout the industry. In terms of its adoption, currently we're at around 40% for EE7, which is pretty good, and also there's a pretty large uptick in spring. And there's still people out there running Java EE5, and hopefully by this time next year we'll have a fairly large contingent on Java EE8. And there's also down on the bottom of the slide there's a link to our survey results. The Java EE ecosystem is one of the few open standards that has such a huge breadth. If you look at over the last 20 years, we've had a large consistency in terms of application containers. Most Java developers consider themselves JSF developers, JAX-RS, they work with JAX-RS. You've had consistency in terms of the platform over the last 20 years, which is really unusual if you look at the history of the computing industry, because the stuff that you were writing in the mid-1980s changed drastically by the time you were in the 1990s. So really from around 2000 till almost 2020, we've had practically 20 years of the same run on the same technology, and you could move between different vendors. So you could start out working on WebLogic, move to TomEE, move back and forth from Glassfish to WebSphere. So you really had flexibility in terms of career and also in terms of tooling and this large ecosystem of tools that grew up around it that would work with it. There's also a push right now with microservices. There's more information up there on the microservice profile, which is moving forward. So the effort utilizes standard Java EE APIs to target microservices problem domain, including highly customized self-contained Uber jars. For more information on that, check out the link on the bottom. So if we look at the history of Java EE, past, present, and future, it's been a steady progression. The thing to remember with Java EE is that it is a standard. You don't go to Java 1 to find out it's not like going to an Apple developer conference where they're going to surprise you with a brand new phone that you've never seen before or some new thing. Java EE, the idea behind Java EE is you take good ideas from the community from multiple companies and then you standardize them so that everybody across the industry can benefit from it. So that you can work with one container and then move over to another container. So it gives you that consistency. So over the years, the Java EE specification has continued to evolve, and as we can see here, we have with Java EE8, the proposal with Servlet 4, JSON-B, etc. And it's an extension of what came along in Java EE7, and hopefully Java EE9 will continue this path forward of standardizing good practices, standardizing technologies, so we have consistency throughout the industry.
Okay, so when Java EE8 was formulated, I was actually in Oracle. So in many ways, Java EE8 is very interesting and frankly a departure compared to pretty much anything that has preceded it and actually ever since. So generally, the scope of things like JavaSIG and Java EE are largely determined by internal architects at Oracle with a little bit of consultation from the major vendors and the major players and maybe one or two community members. In Java EE8, we actually took a completely different approach to doing this. So basically what we did was put together these high-level ideas from these internal architects and major vendors and some community members, and we actually put it in a survey form. And we opened the survey up to anyone that would be interested in providing input. And in that survey, and this was in 2012, we got about 4,500 responses. And actually, this is what helped us determine what exactly should be in Java EE8, and this is how the scope of Java EE8 came about. A long story short, we'll get in a little bit into this. So unfortunately, the Java EE8 survey was not the end of the story. In 2016, Oracle actually did another survey to sort of revalidate the scope of Java EE8. And if you want to look at the survey results of that, you can take a look at it. So the revamped results of what we'll talk about in terms of the delta between the original plan of Java EE8 and the current plan is actually driven by essentially the differential of these two surveys.
So the original plan for Java EE8 included continued enhancements for the web standards, so adding support for HTTP2, JSON binding, MVC, a model view controller architecture finally for Java EE, cloud enhancements for security and a RESTful management API, more work on extending the CDI programming model, closer integration with enterprise Java Beans, and then smaller but important features such as caching, improving JMS, and other revamped iteration of the JMS specification, and finally alignment with Java SE8. And as we'll see, they've changed. Some of this stuff has actually changed since then. So this was the original set of specifications that were to go into Java EE8, the JMS 2.1, JAX-RS 2.1, JSF, CDI, JSON, and then all the way over to MVC, the security API, and the management API. And as we go through this presentation, there'll be little red X's that appear on the slides for the specifications that have since been dropped by Oracle and that are not being released. At Java 1 2016, they announced the Java EE8 reboot, and so they proposed a number of JSRs to be dropped. So they proposed, and actually did drop, the Management 2.0, JMS, and the MVC. The MVC framework, which was actually mostly done at the time that they dropped it, was turned over to the community, and on that portion of the presentation, there's a link where you can actually download and actually actually use the MVC implementation that was meant to go out. They expanded the scope with the security API and also proposed new JSRs, which have since ended up in Java EE9, such as health checking and configuration. This slide's a little bit out of date in that the survey, we saw the survey results on the previous slide, and the target release is next month. So there'll be quite a bit of news with that. This is basically just a slide updating from Linda, now a little bit dated. The target release dates, which is now June of 2017, and thus far they're holding to this. So by next month you'll have Java EE8 to play with, and hopefully we'll be talking about Java EE9.
So one of the biggest ticket items so far, or the original plan and the complete plan, is actually support for Servlet 4.0. So that is obviously, as Ryan mentioned, the release date is very, very soon. So in fact, Servlet 4.0 is all but done. It's actually in public review state, which is all but the final state. And you do have a reference implementation already available, both in Glassfish 5 as well as there's an early implementation in Tomcat 9 as well. So both are things you could check out. So what exactly is in Servlet 4.0? Well, the big change here is actually support for HTTP 2.0. How many people here know about HTTP 2.0? Okay, just a handful of people. So let's talk a little bit about what HTTP 2.0 is. HTTP 2.0 is basically a modernization, a long-standing modernization of the HTTP protocol for today's web as opposed to yesterday's web. So yesterday's web, if you were back in the day, you were around and you saw things like NSCA Mosaic, the web pages looked a lot like Wikipedia pages. Okay, so it was basically a single page with some text, some hyperlinks, and some very minor text formatting, and that's really it. When you rendered a page, that's all you would get. So the HTTP 1 standard was geared towards that world. Right? So you would do a single GET request, and in that GET request you would get a single resource and you would render it. Right? Once somebody clicks on a hyperlink, well, you would do another GET request and render that page. So today's web obviously is very different from that world. So if there are some statistics out there that basically once you load the average page, let's say on CNN or let's say BBC, you're actually loading on average about 40 resources to render that page. So it's 1 versus 40 resources. So applying HTTP 1.0 to that world actually means that you wind up making on average about 40 different connections before you're able to render that page. So that obviously is a paradigm mismatch. Right? So we need to do something different with HTTP to make it optimized. And essentially this is exactly what HTTP 2.0 is. So it recognizes the fact that there is this issue of loading a lot of resources, and it's not simply just a matter of rendering some text, and there's going to be a bunch of related resources. So it basically takes advantage of that fact. And the fundamental difference between HTTP 1.0 and HTTP 2.0 is that it reuses the connection. Okay, so instead of creating 40 different connections and 40 different requests, there's actually just one request, and essentially a reuse of that connection to load all of those 41 resources altogether. So the key differences between HTTP 1.0 and HTTP 2.0 are these, the ones that are listed. So first of all, everything actually happens in binary as opposed to in text. So that alone gives you a performance boost. As I mentioned, the connection is fully multiplexed in order, which means that it's much like old school TCP connections. Right? So you're literally going back and forth, reusing that same connection and simultaneously exchanging all of this data back and forth. And also, there's some other optimization techniques like header compression. So each time you did these 40 different requests, you would exchange headers. And what actually turns out happening is that all of these headers look very, very similar. So when you are reusing this connection, you can actually optimize on the headers as well. So you can only exchange the headers that actually change, as opposed to exchanging every single header every time. Lastly, there's also yet another feature called server push. And what this allows you to do is push some optimization on the server side as well. So when you request that initial index page, let's say on CNN.com, what the server can do is say, okay, I know that you're requesting index.html, but I have these other 40 other resources that I know are going to be loaded on this page. So instead of waiting for the browser to make all of those requests, the server simply proactively pushes all these resources back down to the browser. So there is no need for the browser even to bother making those requests at all. So those resources will be available immediately as soon as you essentially request the index.html page. A little bit about browser support. To be honest, HTTP 2.0 has been out for quite a while. The major browsers actually do support it. The server-side support is obviously has been a little bit slower, but the Apache server does support it, and hopefully now with Servlet 4.0, essentially every single servlet engine will also support HTTP 2.0. I think I went over this already.
Does that require JAX-RS also?
It does not. No, there is a way around that. So it could require JAX-RS, but what the Servlet 4.0 EG did is actually do a backport of part of JAX-RS. So just the HTTP client API portion, right? It's backported as a essentially a under the hood feature. Right? So that's available.
So HTTP 2 will work even on Java 8. If I run Tomcat on Java 9 on Java 8, with HTTP 2 will still work.
Exactly, because of that backport.
So moving on, JMS 2.1 was actually one of the specifications that they dropped development on. It stopped about last December. So there are no new builds available for testing and only actually early planning documents that are available for it. So they have dropped it from EE8. For EE9, Java 1 last year, they were talking about introducing some new messaging services, somewhat similar to what you have up on the Amazon platform. I was joking at the time that I thought that they had grabbed screenshots from the Amazon site with some of the messaging solutions they were proposing to add. So with JMS 2.1, it was supposed to be a minor release. JMS 2.0 was actually the major release, the first major release in a very long time. The original objective was a continuation, continued modernization of the API, adding support for declarative message listeners, adding an alternative for message-driven beans, so you did not always have to use a message-driven bean, adding more powerful features to it, making it available to all beans within the system, adding support for things like dead message queues, redelivery behavior on JMS rollback, etc. But it was in a very early state of development at the time that they actually canceled it, so we'll never actually know what it would have been. One of the features that they were also talking about adding was asynchronous message batches, being able to receive batches of messages in one go. So some of these features would have been nice if they could have added them, but that has been dropped. Maybe a future release of it. This is just another example of what the asynchronous batch API would have looked like if it had made it into EE8. Declarative message listeners as well. So this was the proposed API that they've since dropped. With that, JAX-RS.
Okay, so JAX-RS 2.0 was actually a good solid release. In 2.1, it's basically minor enhancements that are well requested by the JAX-RS community. So what are these? Basically, a few different things. One is adding reactive API support. I'll talk about precisely what that is, and also support for SFC. Again, I'll talk a bit more about what that is in a second. And also integration with JSON binding. JSON binding is an API we'll talk about shortly as well. But what this means is essentially native support for JSON to Java binding built right into the JAX-RS providers. Okay, so this is really what the reactive support actually means. For those of you who are not aware, a completion stage was actually an API that was added in JAVASIG 8. Okay, so what the completion stage API allows you to do is write essentially promises in Java. So if you're familiar with JavaScript promises, this is basically Java's version of promises. Or if you've used, for example, the Netflix, what's that API? Anyway, and then Netflix has a reactive API to do essentially what completable feature does, but basically promises. So essentially what this JAX-RS 2.1 feature does is that it adopts the completion stage API into the JAX-RS client. So now you can actually make meaningful and fairly complex reactive style, promise style calls using the JAX-RS client. So I have an example here. So instead of just making a simple async call, I'm doing .rx, which basically will make this request reactive. So when I actually do a GET request, the GET request doesn't actually execute. What I actually get is simply a handle to a future GET request call. Similarly, I'm doing another call like this to get the suppliers and the partners. Now, what I can do is I can asynchronously execute both of those tasks, okay, and asynchronously combine them. And basically, this is all happening without any blocking happening whatsoever. So when I say then combine, it's basically executing both of those asynchronous requests together. And once both of those asynchronous requests are done, only then do I combine, and I finally get another list combining both of my lists. And even that is a completion state. So I could even add further more asynchronous behavior to it. Server-sent events is basically a holdover from Java EE7 in a way. So in Java EE7, what was added was WebSocket support. And that was a separate API altogether. It's called the Java API for WebSocket. But other than WebSocket, there's actually yet another HTML5 API that was created besides WebSocket called server-sent events that wasn't actually standardized as part of Java EE7. So the question is, what is server-sent events exactly? So in order to understand server-side events, you really have to understand the continuum between plain HTTP, server-sent events, and WebSockets. Plain HTTP, we all know, it's just a request-response model, right? You make a single request and you get a response back. It is always one directional, right? You're always making a request from the client to the server each time. WebSocket, on the other hand, is the opposite extreme. Okay, so in WebSockets, you're literally utilizing the underlying HTTP connection as a TCP socket. Okay, so what that means is you have full duplex communication. Okay? So you can either the client or the server can initiate a request, okay, and either the client or the server can produce a response. So that's useful in things. The canonical example for that would be a chat application. Server-sent events is basically something in the middle. Right? So what is this? So what server-sent events is basically server to client streaming. Okay? what that means is that the client makes an initial request, but it doesn't expect just one atomic response. Okay? What it expects instead is a units of responses over a period of time, a stream of responses over a period of time. So some examples of this would be, your classical stock ticker example. So you subscribe to an endpoint, and it's a stock ticker. So each time there's a stock update, you get an update back. Similarly, any kind of monitoring application would have the same sort of dynamic, right? So you connect up to something that you're monitoring, and it would send you events over time as to what exactly is changing. So actually, under the hood, server-sent events is really nothing much more than a long-lived HTTP connection, an HTTP connection whereby the client and the server agree that they're not going to terminate the connection very soon. And besides this, the only other quirk for it is that it has a specific content type. So whenever the browser or the server is seeing content type of text slash event stream, that means that it's actually a server-sent event. So another thing to know is that actually, although it wasn't standardized in Java EE7, most implementations of JAX-RS 2.0 actually had support for server-sent events in a non-standard way. Certainly Jersey did. So actually, what got standardized in the end is very much exactly what was in Jersey for a little while. So here's an example. So here you have a stock ticker path. So this is your REST path where you're publishing the stock ticker information. You make an initial GET request, and that maps to this GET quotes method. And what actually produced is that magic text slash event stream object representing a server-sent event. And notice the return type of this is actually void. Okay, so we don't actually return anything after this GET request. What do we do instead? What we do is we create something called a SSC event sync. Okay, so you get a handle to the SSC event sync, and you also can get a handle to the actual SSC object. The event sync is literally your pipe. Okay, so you say sync.onNext, sync.close, right? So sync.onNext means send the next message down the wire. So send the next event down. Sync.close simply means close up, finally close up this connection. I'm done with this. Please terminate the persistent connection. And what SSC allows you to do is that it is a handle to creating new events. Okay, so it renders the events in a way that can be consumed by this API. So if you have a series of stock codes that you're executing on another thread, like I am doing here, using executor service.execute, this is running in a separate thread, and it's listening to something, okay, that generates these stock codes. And each time I receive one, I simply say new event, and I'm sending these stock codes down the wire as server-sent events.
So JSF 2.3 is coming in Java EE8. The specification is in active development currently. There are milestones now available for testing, so you can actually download it, play with it, and provide feedback on this JSR. With JSF 2.3, things that they've targeted is standardizing the WebSocket integration. So we now have an F:\WebSocket giving components access to the WebSocket communication with the server. Multi-field validation, finally date-to-time support, enhanced CDI integration, lifecycle enhancements, so we now have a post-rendered view element with it, extensions to the expression language API, configuration improvements and enhancements, and also enhancements on the AJAX support. So looking at a couple of the features, because it's a fairly large specification, we now finally have the ability to inject the faces context, so you don't have to create your own producer and do the injection yourself, or sorry, create your own mechanism for doing this, as well as the ability to easily access the application map and have that injected. So these are two minor but major enhancements. Wider support of injection into JSF artifacts, so you can now do injections with converters, validators, behaviors, and also upgraded to CDI qualifiers.
Okay, CDI 2.0 is interesting. The reason is, although we've had CDI releases both in Java EE7 and actually after Java EE7. Java EE7 there was a CDI 1.1 release, and then after Java EE7 there's actually has been a CDI 1.2 release before Java EE8. Both of those were relatively minor in that a lot of the changes were relatively small grained. So in CDI 2.0, what they decided to do is actually take a major step forward. And actually they did something very similar to what the Java EE spec itself did. So the CDI 2.0 changes were also driven by the CDI community. So they came up with a list of changes, and they presented those changes to the community, and the community voted on what actually they wanted. And what they wound up is something like this. So first and foremost, they standardized a Java SE bootstrap API. So this is actually more complex than it sounds, because CDI 2.0, CDI is a spec essentially geared towards Java EE. So there's a lot of Java EE specific features in CDI 2.0. So in order for CDI to work in a Java SE environment, you actually had to modularize the specification and say, okay, this is a version of CDI that only targets Java SE. These features will only work in Java SE and Java EE, and now there's also a separate Java EE version of CDI 2.2 as well. So what that means is there's a superset of features that only work in a Java EE environment. And of course, the Bootstrap API itself, which is basically saying something like new CDI container, right, and allowing you to bootstrap in a Java SE environment. The big reason actually this is important is because of third-party software development. So what this enables is the third-party software developers now being able to create CDI modules that actually work in Java SE outside of a Java EE environment. And the other big change, big ticket change is asynchronous events. I'll talk about that in a second through some code examples. The ones that I won't talk about is a lot of simplifications to the portable extensions API. Again, one of the nicest features of CDI 2.0 is that it is really the most extensible API in Java EE. In fact, I would say even in the open source domain, it's difficult to find a API that is extensible to the point where CDI is. There's an entire portable extensions API essentially geared towards empowering third-party library developers. So there's a bunch of actually small grain changes that took place to add more features and simplify that portable extensions API. And there's actually a longer list, about 20-some lists of small grain changes here and there that I won't really cover. I'll just cover the big ticket features, which is the SE bootstrap and the asynchronous events. So this is what asynchronous events look like. CDI comes with its own event bus. Okay, so you can actually fire and consume CDI events. Those events, as of CDI 1.2, were synchronous, which means when you fired an event, and essentially it would go into a synchronous blocking queue, okay, until the receiver receives it. So, which is fine. In most of the cases, that's probably fine. But if you were to make CDI events a little bit more reactive and use it in a much more non-blocking fashion, you need a bit more than that. So this is actually what this provides, is that now you can actually trigger CDI events that are completely asynchronous. Okay, so which means as the moment you trigger the event, it works most like JMS. It goes into the JMS message bus asynchronously and is received asynchronously as well. So it's as simple as simply adding a fire async method. Okay, so prior to that, it was just event.fire, and that you would fire a synchronous event. Now you can essentially fire an asynchronous event. This is actually has to do with something else that was in scope for Java EE8 initially. And that was actually in Java EE7 and to some degree in Java EE6. What happened was that CDI was aligned to become essentially the replacement of EJB. So all of the features that were available in EJB were piecemeal being sort of farmed out to different specifications. One good example of this is in Java EE7, the transactional annotation was actually pulled out of EJB and put into JTA. Okay, so one of the things that were in scope for Java EE8 was actually doing that for the rest of the EJB spec annotations, things like at schedule and at asynchronous.
Quick question.
Yes.
Does at schedule go use the timer tags for the new API?
The idea here was to essentially put it, and this is internal, and this is never actually published. So the idea here was to actually put it in the concurrency utilities. The concurrency utilities has a very minimal scheduling functionality built into it. If you look at it, it actually has a triggering mechanism.
And can I replace it with an external? Can I point it to something like a quartz or a...
No, I don't think that was ever the plan. But basically, the plan here was basically to put it in the concurrency utility stack. But obviously, because of the realignment and rescoping of Java EE8, this actually didn't make it. So hopefully, in a future revision, they'll do away with at least the two remaining big EJB annotations, which is at schedule and at asynchronous.
So JSON-P. JSON-P has been actively developed for Java EE8. It's now in public review mode, I believe. So it's the JSON, the ability to patch JSON structures. So it updates, it's a new API in Java EE7. Sorry, it updates a new API that was added in Java EE7. So in Java EE7, we've got basic support for parsing JSON, and this takes it to the next level. So as part of this, we have JSON pointer and also JSON patch. And basically, these are editing operations on JSON objects, making it easier to work with the JSON data structures to replace pieces of the JSON data structure and alter it. So it's some helper classes and enhancements to the existing support. So it ties in support for Java 8 streams. So this is an example here of working through where we're using streams on the JSON API to process and filter a stream of JSON data coming through the system. So in this case right here, we're actually filtering for people where their age is greater than 65, and then printing out for each one of them their name. So this is iterating over a JSON data structure, doing filtering, and also printing out the name. So this is tying the JSON support in EE7, pulling it into the EE8 world, allowing us to work with it using Java 8 streams. The pointer support, so this allows us, basically you can think of this as XPath for JSON, so it allows us to easily navigate and pick out pieces of data out of a JSON data file, which would be pretty hard to do with the support that's in Java EE7 right now. So in this case here, I'm creating a pointer object that points to the first mobile record, and I want to pluck the mobile phone number out. So it makes it easy to navigate and to drill into JSON data structures. This is another patch example. So in this example here, I'm building up a JSON patch builder, and then I'm actually replacing, removing, adding, testing to see a bunch of different operations that I'm performing on the JSON data structure. So I'm replacing one of the age nodes with 30, setting the value of 30, removing the phone number, testing to see if the first name property is set to John. So it allows us to do a bunch of things that were very hard to do previously, and that you may have used third-party libraries that were non-standard to try to accomplish this.
Okay, so Java EE management 2.0. I guess let me skip this over and go to the next slide. What is it? So this was initially proposed as part of the initial scope of Java EE8. So what is it? What it is basically a way of managing app servers. And believe it or not, you can actually do this today. So today the API that exists for managing app servers is actually based on EJB 2.0. It was added in, believe it or not, in the J2EE 1.4 timeframe. So the idea here was to modernize the API, and instead of using EJB remoting, essentially use REST and SSC to be able to do this. So do things like restart the server or deploy a new artifact or getting some monitoring information. So instead of doing the EJB API, doing this in a much more modern fashion in terms of using modern protocols. In reality, to be honest, most app servers today do this already. Right? Most app servers, if you look at it today, they provide a REST-based API and they provide SSC support. Certainly JBoss does, and certainly Glassfish does. WebLogic does as well, and in fact WebSphere does as well. So unfortunately, this API, when they redid the survey in 2016, this is one of the lowest voted items. So they actually wound up dropping this API. I think this API will surface in a different way in Java EE9 is my suspicion.
So in Java EE8, one of the proposals is for bean validation 2.0. So with bean validation 2.0 is adding support for local time and optional. It's leveraging the annotations and repeatable annotations, which we have another slide on, and we'll talk about. The potential enhancements which actually, the slide's a little bit out of date, but they were talking about at the time was customized constraint validations, being able to do validation of an object graph. So for example, being able to, on a list, say, enforce that that a list of strings was actually a list of email addresses. So finally being able to do the support with bean validation.
Okay, so there is going to be a minor JPA update with Java EE8. Principally what it will do is a few things. Number one, which I'll show you in a second, is basically make all of the JPA annotations repeatable. Okay, so using the Java SE8 alignment support. The other big ticket feature in JPA update is also related to Java SE8, namely adding support for the new datetime API. So if you look at my example here, I have a private instant as a JPA field. So today, if you were to use this in JPA 2.1, this wouldn't work because this is a type that the JPA provider, unless there's specific support for it, wouldn't recognize. This would essentially be serialized as yet another object, as opposed to being serialized as a temporal type, just like any other temporal like date, Java util date would. So in JPA, in the JPA revision, this will essentially be fixed, right? So there'll be native support for all of the new datetime API objects. So this instant, in fact, will be correctly rendered back and forth from the database natively in the JPA update. Okay, so MVC is actually an interesting case. So MVC actually there was weak support in the original survey, in the original Java 8 survey. Barely about 52% of people actually wanted an MVC framework. And unfortunately, in the new survey, it really dropped down the support for MVC. So that's why they wound up cutting MVC. So let's talk about exactly what this is. The idea here is actually to create a peer for JSF. JSF is a component-based framework, and it was a component-based framework written by somebody who actually wrote the first action-based framework in Java, Craig McClanahan. Okay, so Craig McClanahan created struts, but then when it came to standardizing a view layer framework in Java EE, he decided to go the component-based approach because he felt that was the better way of writing a web API, and that's how really JSF was born. But and JSF has been very successful, frankly. JSF still continues to have a very strong ecosystem. But the problem was, all throughout these years, there's always been a school of thought that says there should be another standard way of writing web frameworks. Namely, it's the old struts style, action-based framework style. Okay, so this actually, the real reason we even put this question of creating an action-based framework in the Java EE8 survey was actually to put it to rest, to be honest. We weren't expecting more than a handful to vote for this, to say, yeah, we do want another API, another web layer API, but it turns out there was, right? It's still slightly more than half. It's still slightly more than half, right? That wanted this. So that was the reason that this API was launched. So it's basically a standards-based action-style API. So the idea here was basically to essentially take pieces of Java EE and create an action-based framework. So the model would be basically CDI being validation in JPA. The view would be the existing view layer technologies, namely facelets and JSP. And in fact, the reference implementation for MVC actually supports more than this. It supports time leaf and even velocity and free marker as view layer technologies. The real trick really here was the controller. Controller was where most of the work was going to be. And actually even that is relatively thin work because by and large the decision that they wound up making is to leverage, for the most part, JAX-RS for the controller. So the final programming model would be something like this. Right? So you would just have a add controller annotation, a new annotation to differentiate the JAX-RS, the MVC controllers from a normal JAX-RS endpoint. But other than that, by and large, just JAX-RS annotation. So path annotation from JAX-RS to denote a path, get, post, put annotations again from JAX-RS, produces, consumes annotations again from JAX-RS. But with one exception, one notable exception really, and that's the view annotation. I mean, that's basically saying, okay, use this controller for a given view. Right? So basically, almost just a reuse of JAX-RS and CDI to create a new action-based web framework that looks very familiar to folks that are already working with Java EE technologies. Just to give you a quick example of the view of the model rather. So you would create inject a model object. You would put in some. You would return a string, get item, or return the view name that you're going to go to. And in the model, you will inject whatever value it is that you need. For example, you could essentially put in a customer name or an item name. So in your view, you would put in a customer object that has a field called name, or an item object that has an ID. So relatively straightforward implementation. So what wound up happening is because the MVC API in the renewed survey got such low votes, they essentially cut it officially as an Oracle supported GSR. But there was enough momentum behind the MVC specification, and as Ryan said, a lot of the work was already done at that stage. So what they did was actually, instead of simply dropping it, they actually gave that MVC specification over to the community, to most of the people that were actually actively participating in MVC. So although MVC won't be part of the July release in Java EE8, I think we'll see the MVC spec outside of Java EE, but still an API targeting the Java EE APIs probably by end of this year anyway.
So JSON-B, or JSON for binding. So JSON-B, what's being added to the platform is the ability to bind JSON objects to Java objects, much like you get with JPA or JAX-B. So this is currently in public review. The link is up there so you can actually check out the documentation and download it. So as I mentioned, it standardizes the means of converting JSON to Java objects and vice versa. Basically, you use something like JAX-RS for today, and JAX-RS, I believe, will be a reference implementation going forward, and they're actually trying to match the performance of it to JAX-RS. The default mapping algorithm, so they have a default mapping algorithm for converting to Java classes. So they've looked at the existing open source packages that are out there, and basically use those as a template for creating the specification. So this basically provides a standard way for JAX-RS to receive a JSON input and convert it to Java objects for you automatically. So this is an example here of converting. You have over on the left your Java object annotated on the left, and then gets converted using the JSON-B API over to JSON for you. So the proposed custom mapping, so with this they're adding some custom annotations to control what gets converted over and how it gets converted over. So for instance, if you want to rename a field, use a different name than the Java property name, control whether something gets serialized or not to JSON. So that's really what the annotations that they've added control.
Okay, so Java EE is an interesting one. Java EE security is actually hasn't been upgraded in a long time. In fact, there is actually no such thing as something called Java EE security, believe it or not. What is there in Java EE today is by and large bits and pieces of various APIs, namely JASPIC, Jazz, and various bits and pieces in the servlet spec and the like. So the reason Java EE has been able to get away with this is because a lot of the actual functionality to secure Java EE applications is actually vendor specific. So if you go to secure a Java EE application, by and large what you do today is you declare what the authentication method is, let's say basic or certificate or what have you, and you do some role-based configuration to say, okay, this URL should be secured and these are the roles that are allowed to access it. But other than this, things like, okay, so what am I securing this application against? Is it LDAP? Is it database? What is the database configuration? A lot of that work is actually done via application server configuration, usually through a graphical user utility in the console, or some other command line based utility. The problem with that approach is that it's not very portable, right? So all of the work is basically outside of the application. It's done in a vendor specific way. So what the goal of Java EE security is actually to do both, right? So we want to maintain that capability of being able to define security outside of an application, but in addition to that, the goal here is to actually provide an API so that you can secure an application in an embedded fashion within the application itself. Okay, so there's various ways, various features that have gone into to do that. I'll talk about a few of them very briefly. Namely, one of them is simple security providers. I'll talk about that in a second. Simple pluggability API. I'll talk about that in a second too. A universal security context. I'll discuss this. And also enabling the security annotations for all beans as opposed to just EJBs and servlets today. EL enabled annotations, again I'll discuss this in a second. Also in consideration was OAuth OpenID and JWT support. This part actually was deferred to Java EE9 because there was already a lot of work to be accomplished in the time frame that was left to actually implement Java EE8. So there's some interesting examples actually you can take a look at on GitHub. Most of what I'll show you in the code examples actually comes from these those examples on GitHub. So first and foremost is what the Java EE security API will provide now is some built-in annotations, simple annotations that you can place into your application to do that piece that you would normally do using the app server's GUI console or some other configuration mechanism. So it's as simple as, okay, I want to secure against a database. Well, I just say add database identity store definition, and I define what data source I want to secure against. Similarly for LDAP, okay, these are the two built-in ones that are available. There's also an embedded one available, not in the spec but in the RI. Okay, so that's one way of making security a bit more embeddable in the application. Now, what happens if you're not securing against a database or LDAP or an embedded sort of name-value pairs? What happens then? Or what if your database or LDAP doesn't really follow any standard format? What do you do then? So the answer today is to write essentially JAS plugins. Okay, JAS plugins are actually not intended for end users per se. They're intended largely for vendors. So the API is very complex and it's also relatively old. The last time that was updated again was in the J2E 1.4 era. So in the new security API in Java 8, basically if you run into this scenario, you have an easy solution. The easy solution is actually just something like this, right? You just write a simple POJO, you annotate it with the security provider annotation. What that means is this is your custom security provider, and it's just got some very simple callbacks, right? So on authentication and on authorization. So if you have basic authentication, that means you're going to get a username and password. You do whatever it is that you need to do there, and you return a principal object. Again, for authorization, well, you've given the principal back that you just sent back, and then you send what the corresponding roles should be. More again around this vein. So today, if you let's say for a second that Java EE security is role based security. Right? So there's a add roles allowed annotation, and you can you can basically list what roles should access a particular method or URL. What happens if you want something a bit more complex than that? Well, your options today is actually to write something like this as of the new Java EE security API. There's versions of this available in API specific ways today. Right? So you can do something very similar to this, which is essentially writing your custom interceptor, okay, in CDI specific ways and EJB specific ways and servlet specific ways. So what this is basically a unification of all of those. Right? So now this is the API to do all of that. Right? So it's basically a single API called security context. So over here I'm defining a CDI interceptor. It's called access logged. Okay, so that's when I put this bound to my access logged annotation. So wherever I want access logs to occur, I'll simply annotate my method, my client method, with the access logged annotation. and that will trigger essentially this interceptor whenever that method or class is invoked. So what the security context annotation object has, the injected security context has, is all of this security information that's currently available to the container. Namely, what is the current principal, okay? And is the current principal against a given role. So what that means is you can now create your own rules, whatever rules it is that you need. If it's much more complex than simply a listing a role, well, you can essentially create your own logic. Now, another idea that was deferred because there wasn't enough time in Java 8 was this. So this is basically the middle ground between role-based security and writing your custom interceptor, and that is basically having these little snippets of EL expressions, okay, that you can execute. Okay, so hopefully, again, there wasn't enough time to do this in Java 8. Hopefully, in Java 9, we'll see this as well. Let me just cover this real quick because we just have 5 minutes left. JCache is another one that was slated to be included in Java EE8 originally. Again, not that many votes in the new poll, so this was essentially dropped, which is okay in a way. So you can actually already use JCache in Java EE application. It's just a drag and drop jar file, so to me this is really not that big of a deal. Another big change, actually I referred to this when I talked about JPA. Basically, in Java SE8, you have the capability of repeating annotations now. So in Java E7, you had to do this. Right? So if you had 2 different annotations, you needed to add a wrapper annotation, and there were a number of these called named queries. So in Java SE8, there's no longer a reason to do this. You can actually repeat annotations in the same method or class structure. Right? So this is actually support that's added in a number of APIs. A lot of it is in JPA, but there's also same thing for the data source, existing data source annotations. Same thing also for the existing JMS annotations. So all of the major ones basically are capable of doing repeated annotations now.
So with Java 1 last year, they solicited feedback through the surveys and launched the Java EE Next JSRs, which we talked about. Java EE8 is on target for release next month. So this is the roadmap that Oracle released last year at Java 1. So they laid out what they were doing the end of 2016, 2017, and so far they're holding to their 2017 plan with Java EE8 with the release coming out in June. So they're fairly well on target with that. There's also defined work that's going on for Java EE9, although not really currently. So it's very hard to find any update out there online for what's going on with Java EE9. There's definitely no builds out there yet for Java EE9 in terms of implementation. They had a very aggressive schedule that they sent out at Java 1 last year, which was to have Java EE9 released in 2018. So 2017 would be Java EE8, 2018 would be Java EE9, or that was at least the plan. At this point, I don't know if that will actually pan out.
So these are the various things that are on the slate for Java EE9. And believe it or not, actually, Oracle promised to deliver all of this in Java EE8, which is, again, in end of year 2018. I think it's unrealistic. Really, it's far too much, and a lot of this is sort of very out there things that there's very little industry consensus on. One, the value proposition of these into a standard, and how these APIs will even actually look like. But either case, there's some obvious things, right? So the OAuth, OpenID, JWT, that was deferred. Some of the security items were deferred. Dynamic configuration is something also relatively cut and dry. Creating fat jars and modularity, again, relatively straightforward. The health check and metrics, it's really just a subset of the other API, the Java EE management API. The rest of these, I think, are less than clear. So we'll see what happens with Java EE9. Actually, I believe that the vendors, in fact, I know that the vendors are negotiating behind the scenes to see what actually makes sense to standardize in Java EE9 right away. But the good news is actually a lot of this stuff is one, it's already available in the Java EE ecosystem. If you look at projects like Wildfly Swarm, for example, a lot of these features are already built into it. So basically, they've taken the core of the Java EE APIs and they've added all these things for the most part. Right? And also the microprofile initiative that Ryan mentioned earlier, what they are doing is actually taking that work, okay, and not quite putting it into the JCP yet, but basically collaborating via open source so that multiple implementations, actually all of the implementations of the microprofile initiative will actually support for the most part these feature sets, right? To a lesser degree or the other. So I think that creates some more runway and not sort of aiming for the sky in the Java 8 timeframe. In fact, I don't even think that's a right thing to do anyway.
So in terms of playing with Java EE8, you can download the Glassfish 5 release or the version from Pyra today. Play with Tomcat 9. So there are milestones and documentation available for you to download and begin looking at today. So definitely do take a look at that. Java EE8 resources. There's information. The first link up there is for the presentation last year from Java 1. Arjun has a very good website where he posts the different statuses of the different specifications along with articles. So that's usually a very good place to look to see what's going on with that. The Java 1 sessions from last year, and then also the umbrella specification, the overarching specification. And how Java EE8 basically got moving again was the Java EE Guardians. So last year basically collected statistics showing that there was this complete drop-off right in the specification work at the time, and that kind of getting that out there in the public kind of got Oracle moving again, and got the big announcements at Java 1 last year. So definitely do consider joining the Java EE Guardians to try to keep the platform moving forward to make sure it doesn't disappear. One of the things I will say with Java EE that a lot of developers, I talked to quite a few people that don't consider themselves Java EE developers, right? However, if you're using, still using JSP pages, or you're working on JSF, or you're using JAX,
or you're affected by any of the APIs that we're talking about. These APIs do not come from a vacuum, right? They are worked through the Java EE specification.
Yeah. So there's, it's just not if you're writing app code. You're a Java EE developer, even if you're not writing code for a large application container. And so that's the main thing. We want to keep this platform alive and kicking because we've had, close to 20 years now of consistency in terms of APIs. You could move from one vendor to another vendor. You could move from being a WebLogic developer to being a WebSphere developer, and you have the same skill set. You weren't like the Silverlight developers, so that when they pulled the plug on that, things were over. So please do. There's a petition. We have petitions. There's also a listing of everybody that supports the Java EE Guardians. And also importantly, adopt a JSR and get involved. There's presentations online. It's now very easy to join the JCP, and get involved in actually reviewing and voting on the specifications. Quite a few of the Java users groups have adopted different JSRs to review. So that's a great way for getting involved.
Okay, and that's it. We'll take any questions that you can have. Certainly we'll explain a bit more about the Java EE Guardians and what went on with Oracle and us. Both of us are actually Java EE Guardians. Both of our JUGs are supporters of the Java EE Guardians as well, the Philly JUG and the Connecticut JUG. So anyway, thank you for staying. And if you have any questions on any of this, we'll stick around for a little bit longer.